reiterate, जितने भी questions हम लोग cover करेंगे, we'll try to cover 4 to 5 questions in this session. Speed में करने की कोशिश करेंगे. I'll mention the template. I'll mention the topic. You will see me struggling over some of the questions because I may not remember all of them anyways. So just make sure you are following through the way I'm trying to think about the problem. Okay. Sometimes it may be in like one go, sometimes it may be like difficult for me to. So when I'm stuck, what I try to do or how I try to solve is what you can observe. Okay. We'll put a timer. So timer is basically going to be used for us to know that we are at time and we no longer have time to solve the problem by exploring. So we'll look at the solution directly and then we'll try to understand the solution part. Okay. So we'll try to follow this approach. Again, the editorials होते हैं, those are behind paid work. So if you want access to the editorials too, I can just send, I can just download them and I can send it to you. It's not a big deal. All right. So the first question that we have is this question. Again, if any of these questions are behind the paid wall, just let me know. I'll send the question description. back, which कर देता हूँ. This is my old code. सीक्वेंस है हमारा, वो मैं इस पे चैट पे भी डाल देता हूँ. तब तक आपको क्वेश्चन पढ़ना शुरू कर सकते. क्वेश्चन का लिंक दीजिए मैंने. Reset the timer. Start the timer. All right. So the question says, this we have to remove minimum. Okay, so we are given strings which contains open brackets and close brackets, which are in lower character, and then we also have lowercase character English words, English characters. The task is to remove minimum number of parentheses in any of the positions so that the resulting parenthesis is a valid and return any valid string. Okay. So what it is trying to say is parenthesis string is given here. So if this is the example input, LeetCode open bracket, this open bracket is getting closed here, this open bracket is getting closed here, this bracket is not getting closed. So this is your final string that you have to send. Okay. Another example, you want to remove minimum number of parentheses to make it a valid string. So another example is this one. Okay, so you start from here. You see this open bracket, close bracket, but there's no open bracket to this. So you want to remove this, and after that you see this open and this closed. So that means it's a valid. So this will be a valid word. All right. So we want to remove minimum number of valid parentheses without having the. Okay, so we want to remove the minimum number of valid parentheses. Okay, so whenever we see a parenthesis problem or minimum parenthesis problem or any kind of a parenthesis problem, think of using stacks. Okay? Stack is a data structure which is first in last out, and any kind of parenthesis or validation वगैरह problem में stacks use होते हैं. Okay? Then try to start thinking about this problem through stacks. So we can start by going through each and every character. Whenever we encounter an open bracket, you can put that in the stack. Okay, and open bracket, put that in the stack. Close bracket, we are going to remove that close bracket from the stack. Okay? Again, close bracket, remove it from the stack. That means valid. And finally, if we encounter another closed and if the stack is empty, that means this is not going to be in my answer. So we want to skip this particular thing. So the invalid cases are going to be whenever the stack is empty. Okay, whenever the stack is empty, you want to okay, you want to remove them. All right, that is one. What else? What if you have cases which are something like this? तो हम लोग नहीं लेंगे. So what if you have case which have you all the open? So in this case, your stack is going to get inserted with all the open brackets, but they don't have closed. So इसका आंसर आना चाहिए just empty string. So in that case, what we can do is we push everything into the stack, and anything that is present in the stack should not be or should not be present in the answer basically. Okay. So this the stack is not empty. I'll have to pass through the stack again to check what are locations the round bracket or this open bracket is present in the stack. So what I'm trying to say is, अगर ये ऐसा होगा तो एक स्टैक लेंगे हम लोग, ठीक है. इस स्टैक में हम लोग इंसर्ट करना शुरू करेंगे. सो आई इंसर्टेड दिस ओपन ब्रैकेट नाउ राइट ऑन द स्टैक. After that, I inserted another open bracket in the stack. Inserted another open bracket in the stack. Okay. So as I keep on opening, and I'm done parsing this whole string. After that, what I have to do is I have to check uh, what open brackets I have in the stack, and those I have to remove from the answer. So my answer is basically going to be whatever is present in my string minus all the index in stack. Okay, that's one. And no, that is one for opening. And for the closing brackets, so for example, if I have all the closing brackets like this, closing brackets ही होंगी हमारे पास में, तो हमारा stack जो है वो हमेशा empty रहेगा, क्योंकि stack में हम लोग सिर्फ open brackets डाल रहे हैं. So stack will be empty, and every time I see a closing bracket and with the stack empty, I can just count the closing ones. तो closing brackets हम लोग count कर सकते हैं. So closing कौन से हैं जिनको valid open नहीं है. So closing are basically your 1, 2, 3 which are present here. These three. Okay. So instead of storing the values, हम लोग उसके इंडेक्स से स्टोर करेंगे. तो 0, 1, 2 ऐसे इंडेक्स से स्टोर करेंगे क्लोजिंग के लिए जो वैलिड नहीं है, और जो वैलिड नहीं है ओपनिंग वो स्टैक में स्टोर किए जाएंगे. ठीक है. Let's start working on this particular problem. So we'll start with the character in S. Okay. The first thing that we check if C is alpha. Okay. If it's an alphabet, then we want to do something. Okay. Else if C is equal to, then open bracket, then we want to do something. Okay. Else if C is equal to a closing bracket, then we want to do something. Okay. Like we said, we need a stack to keep track of the opening bracket. Stack लेते हैं यहाँ पर. Stack, which is this, we need invalid closings. ठीक है. Invalid closing. Going to be like this. All right. Okay. So ये हमारे answers. हम लोग क्या करते हैं, जो अगर अल्फाबेट है तो उसको इग्नोर करते हैं. अगर वो ओपन होगा तो हम लोग उसको स्टैक में इंसर्ट करना चाहते हैं. राइट. स्टैक डॉट अपेंड स्टैक में इंसर्ट कर देते हैं. क्या इंसर्ट करते हैं हम लोग, इसको एनुमरेट करते हैं. एनुमरेट. यू वांट टू इंसर्ट, यू वांट टू इंसर्ट द इंडेक्स. ठीक है. तो इंडेक्स हम लोग यहाँ पर इंसर्ट करते हैं स्टैक में. तो इंडेक्स इंसर्ट हो गया हमारा कि वो ओपन है. तो जब भी हमें क्लोजिंग मिलता है, अगर स्टैक एम्प्टी नहीं है तो हम लोग क्या करेंगे, स्टैक में से पॉप करेंगे एक. okay? अगर स्टैक एम्प्टी है, ओके, अगर स्टैक एम्प्टी नहीं है तो इसके अंदर जाके पॉप करना है हमें एक ओपनिंग ब्रैकेट. अगर ओपनिंग ब्रैकेट नहीं पॉप करना है, बेसिकली उसका इंडेक्स पॉप करना है. अगर स्टैक एम्प्टी नहीं है तो हमें इनवैलिड में उसको इंसर्ट करना पड़ेगा. तो ये इनवैलिड का स्टैक होगा उसका. तो अपेंड आई, तो ये इनवैलिड सारे यहाँ पर आ गए आपको. ठीक है. तो दिस इज व्हाट वी हैव. इसको हम लोग प्रिंट करके देख सकते हैं, या फिर विदाउट प्रिंटिंग इसको हम रन करके देख सकते हैं सबसे पहले. तो ये वाला एग्जांपल लेते हैं. इस एग्जांपल में क्या होने वाला है हमारा, लीड कोड के एग्जांपल में, sorry. So when we start with the LeetCode example, the first thing that we are going to encounter is an opening bracket. Opening bracket is at the 0, 1, 2, 3. Let's do one thing. Let's ignore all the characters for now and only keep brackets. Okay, so that it becomes simpler. If I keep only the brackets, I have opening bracket, closing bracket, opening bracket, closing bracket, and a closing bracket. Okay. So this opening bracket is at the index 0. So my stack is going to get updated to index 0. All right. After that, I see another opening bracket, index 1. Okay, so stack is having 1 in it now. After that, I see my closing bracket. So that means I'm going to pop one item. Okay, closing, I saw closing. I'm here right now. So I saw closing. I pop my stack. So this is getting popped. I see another closing. I pop from my stack again. So my stack became empty now. All right. Now I see another closing here. So as soon as I see closing, my stack is empty. So I'm going to add that closing into the invalid one. So my closing is going to get added here, which is going to be 0, 1, 2, 3, 4. So 4 is my invalid one. Okay. So that is going to make sure that I have invalid ones present only in this. After that, my answer is basically going to be yeah, it's basically whatever is not present in this and whatever is not present in this. Okay, so my answer should be, just think, what do I put my answer in? If I just say answer, so if I see an open bracket, it will take time for me to validate whether it's okay. Let's just do it this way. Let's just build the answer here. Answer, what is my answer going to be?
Original stack minus the invalid closing index.
Original stack minus invalid closing. Original stack plus invalid closing. Okay, so these are going to give me all the ones which are invalid indexes. Correct? So invalid is this. So all invalid index are these. So my answer is basically going to be, let's create a list here. So my answer is going to be for, this is invalid, right? Let me just check. I don't want to do another looping here, so that's why I'm trying to figure out what is the better way of doing it.
स्पेस डॉट जॉइन आणि मग फॉर लूप लावलं तर
We can do that, or the better option is we can just convert this into a set actually. Okay, if we convert this into a set, we can search it in linear time. Okay, so I can just do this for C in S. If enumerate करते हैं इसको, enumerate S करते हैं I comma C. Okay, so मेरा index आ गया, so I have my index here. Enumerate over S if I not in my all invalid index. Okay, then I want to return my C as the answer. Okay, and the expected answer is basically going to be my list, which is string again. So I have to join this back again. Dot join. Shouldn't work. Let's recheck this answer. So what
सर
we did,
ओरिजिनल स्ट्रिंग लेके अपने को इनवैलिड के इंडेक्स मिल गए राइट लास्ट में, तो उतने माइनस किया तो फिर डायरेक्टली स्ट्रिंग ही मिल जाएगा ना.
how will you minus the strings?
ओरिजिनल स्ट्रिंग पे इन्यूमरेट करके जो इनवैलिड है उतना ही निकाल देना है, बाकी तो वैलिड है ना. आंसर में उन्होंने वो रखा है.
So invalid के ऊपर we have to again loop over the invalid, right? For that, how will I, so for example, if I do enumerate here, okay, you're saying check if I is present in the invalid or not, correct? Then checking is again going to be time, it's going to add the time complexity. Yeah, I have to check through all the indexes again. So instead of that, I can use a set. So this is going to be time complexity for this is O of n actually, where n is total number of characters I have or total number of characters I have, and space complexity again is going to be O of n because my stack is going to have n, my invalid closing is also going to have n. Okay. See if this works. It's alpha, very mistake. So is alpha is correct. That's right. Let's just quickly check this. So your answer is going to be from here and join the same sequence. Okay, there you go. Okay, this works. And time complexity is right, space complexity is right. All right, so that got submitted. Can someone check if this is a premium question so that I can send you the editorial on this?
No, I can access that.
Okay, so editorial accessible then?
Yes.
Let's just quickly check. How did they do this? So what they're doing is they're going through each character. If it's C, then they are having something called as balance. If balance is okay,
No, acha, editorial is locked. Subscribe.
editorial is not accessible. Okay, that's fine. I'll just share the editorial. Index is to remove stack. They did the same thing. Okay. After that, they did the same thing. All right. So you don't have to worry about it. Let's check if there's anything. Shorten to cross. No, I don't see anything. ठीक है? I think they should work. Okay. तो इसका सॉल्यूशन यहाँ पर है, आप बाद में रिकॉर्डिंग देख के भी एक्सेस कर सकते हो. Let's move on जल्दी से. Have the timer here, 12 minutes. Let's go to this eighth largest again. See the points. All right. Check if you have access to this question. This is kth largest. All right. The question is asking you're given elements in an array and you want to find out the kth largest element in an array. So, for example, you're given arrays here, which is 3, 2, 1, 5, 6, 4, and the value of k is 2. You want to find second highest value. So, whenever you want to solve any problem which is trying to ask you kth largest, kth smallest, or any kind of k, which basically is a parameter, in that case, you can solve it by two methods. Method number one, or the easiest method, is something called as min heap, max heap, right? Heap based questions. Second method is by using quick sort, right? So we are going to solve it using the easier method, quick sort. Maybe I'll solve in one of the other questions. Okay. So, stop here. All right. So the quick sort basically means what we're trying to do here is what's a heap? I'll just tell you quickly. Okay? So heap is a special data structure where all the numbers are not sorted. Okay? If 1, 2, 3, 4 are present in the heap, then all the numbers are not sorted. It's a tree-based data structure where the node or the root node is going to be either the minimum or the maximum that is present in that whole tree. So for example, if I have nums here, okay, so if I insert, if I call this as a max heap, so max heap is basically the biggest number is going to be on the top always. So your 3 is going to be on the top of the heap. All right. When I get 2 and I try to insert 2 inside, then 2 will get inserted after 3 because 2 is smaller than 3. Okay. When I get 1, 1 is also going to get inserted after 3. Okay. Then after that, I get 5. Okay. Because this is 5, 5 is going to get inserted here, and then 3 is going to get pushed somewhere here. Okay. Sequence of 3 to 1 is not important here. The sequence of 3 to 1 can be anything. The only thing it tries to do is it tries to build a tree in such a way that 5 is going to be always the top element in your heap. Right? In Python, the heap queue is the library which is used. So you see here import heap queue. All right, this heap queue is the library which is used for writing queues, or sorry, writing heaps. Heap queue is going to by default give you a minimum min queue or minimum heap or min heap. All right, so we are going to use that concept. Whenever you say kth largest, you need a min heap. If you say k smallest, you need max heap. Why do you do that? Because we want to find kth smallest, right? So let's say if I keep on inserting, so I can start from here. If I insert 3 here, this is the heap I have. If I insert 2 there, this is the heap I have. If I insert 1 here, okay, now the value of k is 2. I don't want my size of heap to be greater than 2. I want maximum size of heap to be only 2. So if I remove, because the maximum size of heap is going to be only 2, I remove one element from it. Okay, which element do I remove? I'll remove the top element from the heap. Okay, I'll remove the top element from the heap. So 3 gets removed from there. Then I am only left with 2 and 1. So 2 and 1, where 2 is the biggest number, so it's going to be on the top of the heap. All right. After that, I get 5 here. All right. Now 5 is going to get inserted here. Sorry, we want a min heap, right? So in min heap, it is opposite. Min heap, your minimum number is going to be on the top. So you can try to think about this problem from this point of view also. If you have only if you have only these 2 elements, okay, and you want to find the second largest element, then the second largest element is basically this element 2. Okay, if you have 3 elements here, then the second largest element is going to be again same, which is 2. If you have 4 elements, then the second largest element is basically your 3. Okay, if you have 5 elements here, then your second largest element is going to be 5. Correct. So what we are trying to do is, at any given point, we want to keep the k largest element in the heap. Okay, we want to keep the k largest element in the heap. That means largest element should be present in the heap only. Okay, for that we need a min heap, which will always keep storing the k elements, which are the biggest k elements. Everything else will be removed. Okay, first write the code and then I'll let them explain. Min heap is equal to with empty for now. I'm going to start with n in nums. First thing we do is we just push the element into the heap. Okay, heap q dot heap push. We're going to push the element into the heap. We're going to push n in the heap. All right. If need to send the min heap here and n. If length of your min heap is greater than k, right, then you have to do a pop. Heap q dot heap pop. Pop the element and just continue. All right. The heap q heap pop. If it is greater than k, and you want to heap pop from the min heap again. You have to return finally whatever is the top element here. This is what you want to return, because the top element is going to be your minimum number. Oh, sorry, kth largest. So let's take this example where nums is equal to this and k is equal to 4. This is what we have. All right. So we are going to fill the min heap now. Okay, just take a look at this a bit. The min heap is first empty. After that, your min heap is going to have 3 in it. Okay, because we got 3 inserted here. After that, your min heap is going to have 2 in it, because the size is still less than k, right? After that, you are going to have 1 inserted into the min heap. As soon as you insert 1 in the min heap, the size of your min heap is going to be greater than k, which is 2. If it is greater than k, we are going to do a pop. Because this is a min heap, the minimum number is going to get popped, because the minimum number is on the top. So 1 is getting removed from here. Okay. Then you see 5 here. Then you insert 5 here. Again, this is size greater than 2. Because the size is greater than 2, you want to change your min heap. Change your min heap in such a way that the minimum is getting popped now. 2 got popped. Then you have 6. You are inserting 6 into the heap. Size again greater than 2. So you remove the minimum value from your heap. So minimum number is 3. It got removed. Then you insert 4. Again, you see value of k is 2 and the length of your heap is 3. That means you're going to remove the minimum number. Okay. And finally, you have this in the min heap. When you do remove the minimum number, you basically get the kth largest number here, because 5 is the second largest number here from the answer also. Okay. Do min heap and try to solve this. Another technique of solving this is by using quick sort. Okay. So the time complexity of this is O of n for going through all the numbers. Heap push and heap pop are going to have some time complexities. Okay. the time complexity of heap push is O of log n. Okay, and heap pop is again O of 1. But you have to rebalance again, so it is going to be O of log n again. All right. So this is the time complexity. The asymptotic time complexity, which is basically what is the final time complexity of this, is going to be, this is not n, this is basically k. Okay? This is basically k. And because we are doing it all inside the loop, it is going to get multiplied with that. Okay? So the time complexity of this is O of n log k. Okay? K is total number of items that you have in your heap. If k is 2, then that is what it is. So time complexity of this is O of k. And the space complexity of this is O of k, because we are storing it in the heap here. Okay? Whatever is the size of heap is going to be your space complexity. So to submit this, let's try to think about any corner cases that are available. If your nums is empty, then your min heap is also going to be empty, and you're not going to, you cannot pop anything. In that case, you can check the constraints. So constraint basically says your length is always going to be greater than 1, which means this is never empty. If that is never empty, then you don't have to worry about that part. Then you have numbers which are from minus to plus, so you don't have to worry about that. Just submit this. All right. So you see two graphs here. One graph is here and one graph is here. So I think this side, they are using some different technique. Okay, maybe they are using. So you see this bimodal distribution here, right? So this basically is trying to say there are some solutions which are submitted using one technique, and then there are other solutions which are submitted using this other technique. That's why you see this bimodal distribution. You click on this solution, it should show you what type of solution they used. They used min heap, but I think the reason that it is misbehaving for us is because we are doing this here. Pop. You don't have to pop it. You can just use the 0th element, I guess. Also solve. That should improve the time complex. Still not. Try to check one of the solutions. All of these are complex solutions. I don't. Okay, this is just they sorted it and get the whole thing. Why did we use this heap? Is because if you sort this whole thing, okay, if you sort this whole thing, you can get the second largest easily. Second largest is basically going to be second from here. Okay, and the time complexity of sorting is basically O of n log n. But you don't have to sort the whole thing. You just are interested in sorting k elements or getting the top k elements. So you don't have to sort this whole thing. If you can just sort only these two elements and leave everything out, then you should be good, right? So that's why this is a better time complexity than sorting the whole thing. So again, whenever you see a k, that means we are going to look at the heap kind of a solution. Come quickly on to the next one.
So that sort function can be used, no? If suppose they mention exclusively without sort and
They'll tell you not to use sort anyways. So
okay.
pretty sure they'll tell you not to use sort. अगर आप sort करोगे, then there's no point of solving this, right? Because if you sort this whole thing, it is going to be time consuming, and you don't have to sort the whole list. That's the idea. Okay, sorting the whole list is not useful here, because only if you sort couple of you only need to sort two elements here, right? या फिर only because whatever the value is k is that is what you have to sort. You don't need to sort everything. Okay.
Okay.
All right. This next question is binary tree traversal. This might be a premium question, so I'm going to post the details here. Give me a second. काम कर सकते हैं. Premium question.
Earlier was also premium question.
Eighth largest?
Yes.
I don't think so. वो premium था. Premium ऐसे लिख के आता है यहाँ पे. Eighth largest check करो एक बार. 8th largest is 1. 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 8
Yes. Yeah, sir. Subscribe to unlock it, sir.
नहीं वो प्रीमियम नहीं है, दूसरा वाला जो लेटेस्ट अभी भेजा है वो प्रीमियम है।
हाँ, लेटेस्ट वाला प्रीमियम है, मतलब क्वेश्चन दिख सकते हैं, एडिटोरियल का बोल रहा था मैं।
अच्छा एडिटोरियल आप इग्नोर कर सकते हैं क्योंकि हमने सॉल्यूशन देख लिया ना,
ओके।
एडिटोरियल में भी वही किया होगा उन्होंने, एडिटोरियल वंस एडिट हुई है। एक बार स्क्रॉल अप डाउन करता हूँ, अब बाद में वीडियो थोड़ा पॉज वगैरह करके देखते हैं। They are using some video here. So obviously the first solution is going to the sorting the whole thing. Sorting का time complexity का space complexity login. जो दूसरा approach है which is the don't have to sort the whole thing, but sort just a few points. Code में heap का which is very similar to what we did just now. ये है क्विक सिलेक्ट का। क्विक सिलेक्ट थोड़ा सा एडवांस मॉडल या फिर थोड़ा सा एडवांस्ड एल्गोरिथम है, वो क्विक सॉर्ट के सिमिलर होता है। क्विक सिलेक्ट में क्विक सॉर्ट में क्विक सिलेक्ट किया जाता है, एनी टाइम यू सी के स्मॉलेस्ट के लार्जेस्ट उसमें क्विक सॉर्ट लगता है, यूज करके आप सॉल्व कर सकते हो उसको। थोड़ा धीरे धीरे मूव करता हूँ, लुक एट इट लेटर, थोड़ा थोड़ा पॉज करके देखता हूँ। बहुत सारे टेक्निक्स दिए हुए हैं यहाँ पे। Okay, ठीक है, दैट इज इनफ। ये नेक्स्ट वाला है, के लिए आपको ये लगेगा। क्वेश्चन मैंने सेंड कर दिया, ठीक है, डिस्कॉर्ड पर। थोड़ा सा जूम इन करके पढ़ना पड़ेगा मे भी आपको, लेकिन एक्सेसिबल हो गया अभी आपको, ठीक है। ऑलराइट, लेट्स गेट स्टार्टेड विद द क्वेश्चन। Alright, so the question says you are given a binary tree. Binary tree is a tree which has two nodes as children to your root node. So basically, your root node is going to have left and right side, the binary tree. And the question says you want to go through this binary tree in a vertical order traversal. That means your answer should basically be as if you are throwing some arrows from the top. Then this is going to be your first array, this is going to be your second array, this is going to be your third array, this is going to be your fourth array. Okay. So you start from here, 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 all of this. All right. So whenever you have binary tree problems, you can solve the binary tree problems or basically any kind of a grid or tree problems by two kind of approaches. One is something called as DFS or depth first search, or second is a breadth first search. Right? And we're going to take a look at this solo problem and try to see which one is going to fit here, right? So, since we are talking about vertical or a traversal, we need to have, okay, this line is going to be 1, is going to be second one, we have 20.
जो zoom करना याद पड़ रहा है वो.
Sorry, you want me to zoom in?
नो आपने जो इमेज भेजा है ना,
हाँ,
के बाद वो उसका पिक्सेल ब्रेक हो रहा है.
तो डाउनलोड करना पड़ेगा ये.
डाउनलोड करके ही देखा, डाउनलोड करके ही इसको जूम किया. वो डॉट वेब पी है ना, इसलिए पड़ रहा है. जेपीजी वगैरह रहेगा तो नहीं पड़ेगा.
Sure, let me just share you what I see. ये इमेज है ना, वो ये इमेज है जो अभी मैंने डाउनलोड की, वो ये इमेज है. तो जूम इन किया मैंने, देखो नहीं फट रहा. ये इमेज है ना वो,
हाँ,
जब वो मैंने जूम इन किया नहीं फट रहा.
आप किस में ओपन किया, कौन सा ऐप, मतलब क्रोम में ओपन किया क्या?
लेट मी जस्ट ओपन इट अगेन हियर. ओके, ये इमेज है, मैंने क्रोम में ओपन किया, इसको जूम इन किया मैंने.
Okay.
फट.
वैसे जूम, ये वो ऐसे कर्सर नहीं आ रहा है जूम का, देखना पड़ेगा. ऐसे माउस से किया तो वो फट रहा है. ठीक है.
ओके, तो ऑलराइट, आई थिंक यू कैन फिगर इट आउट. ठीक है, क्या हो रहा है वहां पे बेसिकली, जो डिस्कॉर्ड पे है ना, डिस्कॉर्ड से ओपन करके दिखाता हूँ. डिस्कॉर्ड, ठीक है.
डिस्कॉर्ड पे राइट क्लिक करके सेव इमेज, सेव एज किया मैंने. सेव इमेज किया, सेव इमेज एज.
क्वेश्चन है, इसके ऊपर जूम इन किया मैंने, यहाँ पर ओपन इन ब्राउजर बोला, ब्राउजर में ओपन हो गया, यहाँ पर मैंने जूम इन किया, ब्रेक नहीं हो रहा.
ओके, हाँ. इस टाइप.
ऑलराइट, लेट्स कंटिन्यू. ठीक है, सो क्वेश्चन क्या बोल रहा है? सो द क्वेश्चन सेज यू वांट टू डू अ वर्टिकल और अ ट्रैवर्सल ऑफ अ ट्री. So anytime you do a traversal, like I said, there are going to be two techniques, which is your DFS, BFS. After that, when you also think about DFS, you should start thinking about three more types of traversals. There's one which is called as in-order traversal, second one which is pre-order traversal, and third one is a post-order traversal. Whenever a DFS is going to be used, we need a stack. DFS में stack use होता है, BFS में queue use होता है. Okay? The concept is really simple. What it tries to do is, in BFS, it will first go through the first element and then check its children. Okay, process its childrens and then add these childrens into the queue. And after that, again go to the queue and check if there are any children present in the queue. Then go one level below that particular node. Okay, so you basically traverse 3 first, then you traverse 9, 20 first. After that, after you traverse 10 and 15 and 17 like this. So this is BFS traversal, going 3, 9, 20 and 15, 7. That is a BFS traversal. If you look at this solution, we want to take a look at this particular tree in a vertical order traversal. So what we can do is we can basically have numbering here. Okay, so the numbering is going to be, let's say this is 0. Okay, let's say this is 0, your root node is 0. If your root node is 0, then anything on the left of this is going to be -1, anything on the right of that is going to be +1. Okay, so if this is 0, then this is -1. If this is 0, then this is +1. Okay, and then I go here, I have an option of going on the left. If I go on the left, then I have this +1 here, right? So +1, I have to do -1. Then it goes to again 0 back here in the same line of the root node here. From here, I can do a +1 which goes on the next line or on the next column of +1. So the column here becomes +2. So -1, 0, 1 and 2. These are the columns that I have. Okay. And all I need to do is basically fill those columns with the list of nodes that are present in each of those columns. Okay. So what I'm trying to say is I need some, I'll call them column index. Okay. Column index dictionary, which is going to be a default dictionary with list present there. Okay. So list rahega usme, and I want to just add each and every element into that particular list. Okay. And the type of traversal I want to do is going to be BFS traversal, because I start from here, go to the left, start from here, go to the right. When I'm here, I go to the left, I go to the right. Okay. So my root node is going, I need a queue for doing the BFS traversal. So I'm going to use a DQ here. First thing that I do is I insert root node into the queue. So queue dot append. What is the root node? I'm going to insert that into the queue. All right. Uh, After that, I know my column index is this 0 because I started with the root node, correct? So instead of just storing the root node, let's just store the index of the column also. So I'm going to store 0 here. So that is the column index for root node. Okay. Now I want to traverse through the queue until the queue is whole empty. Okay. So queue जब तक empty नहीं होता तब तक मुझे traverse करना है पूरा का पूरा queue. So empty नहीं है queue. So I'm going to do queue dot pop left. Pop left is basically first in last out. First in first out. Okay. Which is your queue. So you want a node here. And in addition to that, you also want to get the current node column index. Okay, you want to get the current node column index. All right, that is what you want to do. Now, whatever is present here is going to get, I want to get this root index. Okay, I want to get this current node column index. So I have 0 dot append whatever the value of my node is, node dot value. So if my so I'm at this 3 right now. I pop 3 out of the queue. The index of 3 or the column index of 3 is 0. Okay, so at 0th index I have 3, and 3 dot value is what I need to append here, because the list this list is requiring only values in it. Okay, nodes values from top to bottom. Okay, so I just need that value there, append only the values. Okay, and if the node is having left, okay, if the node is having left, that means I need to add it to the queue, because I'm trying to do a BFS here. So queue dot append node dot left. Okay, not yet done. Just note the queue that we are adding is going to have two things in it. First is the node, and second, if it is going on the left side, I need to do what are the indexes. Okay, -1. If node dot right is present, then again I need to add the right and left both into the queue. This is going to be +1. And that's all I have to do. First, I need to go on the right side. So this is going to give me the queue. This is my BFS actually. This code that I have written here, this is a BFS code. Breakfast search. Okay, BFS code for a tree. So you have a queue, you insert the root node, check until the queue is empty. You go one by one. So you have node here. So I added 3. After that, I've added 9 into the queue. I've added 20 into the queue. After that, I go to 9 and I check if 9 is having left and right. 9 does not have anything. So nothing, none of the children of 9 are going to add it to the queue. 20 is having children, 15 and 19, 15 and 7. Then 15 and 17 are going to be added into the queue. Because they're added to the queue is always going to have things added from right and things removed from left. Okay, so add is going to be on the right and remove is going to be from the left in the queue. So that's why you see this pop left here. Okay, finally your answer is basically You have this column index here, right? The order should be from left to right. That means we have to first get the keys, sort the keys, and then get the values. Okay, so let's do that. Call index dictionary dot keys. Okay, I need the keys here, and I'm going to convert them into the list, and I'm going to sort them, the sorted list here. Okay, my answer is basically going to be sorted index. This is my sorted index. So after that, my answer is going to be uh, for what are these nodes, right? So vertical nodes in sorry, sorted index in sorted index, and I want to get this particular thing SI. Okay, so my sorted index is going to be achieved from here. So my column index dictionary is basically going to have items which are going to look like something like this. So my column index dictionary is a dictionary which has -1, and then it has 9 in it. Okay, then it has 0, and it has values which are 3 comma 15 in it. Okay, then it has 1 which has value of 20 in it. Then it has 2 which has a value of 7 in it. Okay, so this is my column index dictionary. This is going to be my column index dictionary. All right, and I want to return the answer from left to right, so I need to go get this -1 first. So that's why I've sorted them here, sorted the index of my, or sorted the keys of my dictionary, and then I go from left to right here. Just quickly check if this works. So we have column index, we have q, which is going to have root, and we are going to have 0 in it. If node is getting popped out, q dot pop left, current node column, node dot value, node dot right, index -1, index +1, right index is getting added. Sorry, this is right here, because this is left which is getting added, and this is right which is getting added. Okay, sorted index is that. All right, so what's the time complexity of this? Time complexity of this is because we're going through each and every node. It's the BFS, right? In BFS, we go through each and every node. So it is O of n. There's no other time complexity. Correct? We are just going through each and every node. What is the space complexity? Space complexity is again O of n. All right, because we are going to go through. We need this particular dictionary here. That's why it's O of n. Let's try to run this. Hopefully it works. Okay. This is this. Oh, error. Node. Okay, we missed a corner case. If this is empty, okay, if not root, okay, if your root is empty, then you have to just return an empty list. Right? Just use this as corner cases हो सकते हैं आपके. Don't forget about that. इसका एडिटोरियल है, वो भी आई थिंक कुछ इस तरह का ही करेगा. Going to talk about various techniques. ये कॉलम्स की बात करें, यहाँ पर भी कॉलम इंडेक्स है 0, -1, -2, -3, ऐसा आपका ट्री बनेगा. उसके बाद में what we do is -3. Correct, this is the dictionary. This dictionary is going to have values that are present there. So -3 is going to have 3 in it, -2 is going to have 4 in it, -1 is going to have 9 and 11 in it, 0 is going to have 2, 1 in it, 1 is going to have 8 and 5, 2 is going to have 7. How do we assign them properly? We assign them as we do the BFS. Okay, So as we do the BFS, we assign them properly. So code of BFS is going to be same always. We use this column table here, which is similar to what we do. They have appended here, so instead of appending it here, they have just added it here. No change there. What is this? You got append left, you got right. Okay, they don't have this check, but it's okay. We can do the check and then append into the queue. Have to worry too much about that. Alright. Submit this.
Sir, but how the tree is passed as a parameter to function? Like,
So this is the tree that is passed as a parameter. So this is a tree object. It's a tree node object, and this tree node object is having three properties to it, which is a value, a left, and a right.
okay,
Okay, so it will always pass the root node. Whenever you pass the tree as a parameter, the root node is passed as the parameter.
okay,
The root node is going to have left and right, and once you have the left, then you again go and left and right. Okay.
okay. So that is like recursive, like root node and left and right, again left and right, like that, till the tree ends.
Till the tree ends, correct. It's similar to the decision trees that we see. Left and right, all the way until the tree ends. All right, so the problem statement. So the problem statement basically says you're given a string s which represents an expression. Evaluate this expression and return its value. Okay. You're not allowed to use built-in function, obviously. So what it says is you're given this 3 plus 2 into 2. Then you're given 3 slash 2. Again 3 plus 5 slash 2. Okay. All right. You are not allowed to use eval. Okay. If you use eval, then Python is going to do the evaluation for you and give the solution to you directly. But we are not allowed to use eval, so we have to come up with a solution which can solve this. So whenever you see problems like this, easy calculator, where you have to pass the string to evaluate it, think of it from a point of view of a finite machine. Okay, finite state machine, FSM. All right. In finite state machine, what happens? You are going to go through various states. All right. For example, when you see a number, the expected next state is going to be basically a expression, sorry, operator, okay, or another number, so that you can build the whole number first. Okay. Once you see the operator, the next element should again be a number. Okay. After that, you should see an operator again, then maybe there's another number. Okay. So if you have 4 numbers, then you need to have 2 operators, sorry, 3 operators. Okay. If you have 2 numbers, you need to have at least one, you need to have one operator there. Okay. So I think that is what the idea is. Let's just check. The operators are going to be plus, minus, star, or slash, separated by some number of spaces. So you can ignore the number of spaces that we are talking about here. Right? Okay. Solve this. Plus, minus, star. And then this one. We know that whenever you see this slash, you want to solve that first. plus should be solved after the division. So this takes precedence over this. So first this has to be solved. Okay. There is no. Okay. 3 plus 2 into 2. First we have to do 2 into 2. First we have to do 2 into 2, and then we have to do plus.
2 plus 3. 5 by 2 plus 3. Like, you have to ignore the remainder.
Yeah, I mean first we have to do 5 by 2.
Hmm.
Okay, and after that we have to do 3 plus 2. Integer division basically truncates towards 0. So I think it's fine. Integer division truncates towards. Okay. How do we do this now? So, I have 3 plus 5. 2. And start with 3 plus 2. 2. I need to keep track of all the operators somehow. 3 plus 2 into 2 plus C plus start here. Okay, what about I keep a stack, and the stack is going to have 3 in it. And basically the number, I put the number into the stack. On top of the number, I put the operator.
Uh,
After that, I put a number again. Then I encounter an operator which is star. If I encounter a star, then I take the top number out of it, take the next number and do the multiplication and put it into the stack back again. So my stack is going to basically have a plus and minuses only. And every time or anytime I see this, then I need to solve it before adding it to the stack. Okay. So what I mean to say is I have this s is equal to 3 plus 2 into 2, correct? So stack which will have 3, then it will have plus in it. Okay. Or it will have 3 in it. After that, it will have this can be written as something like this. Okay. Plus 2. Correct. So this is what I'm trying to say. अगर ये minus होगा तो if this was minus, I'll just do this. For minus, I'll just do this. But it is plus, so I don't have to worry about the sign. So let's say this is the number I have. Okay. So given this, what I need to do is first I need to insert 3. After that, I need to insert 2. Okay. After that, I encountered star. When I encountered star, I will pop it from the, I'll pop the top element and I will multiply the next element with it. Okay. And then put the whole answer back into it. Okay. So I need to keep track when I check this particular star. Okay. So I need to keep track of something which is the operator. Okay. I need to keep track of an operator. So what is my current operator? Okay. Current operator is basically going to decide whether I need to push or pop into the stack. Okay. So to start off with, current operator is nothing. I need a stack. It's obvious. Okay. Because I need to put the values into the stack. Okay. Let's see. What else can we do in it? We are given 3 plus 2 into star, right? So we need to split the whole thing in such a way that the numbers are different, and then we also have operators. Okay. All right. So let's just split the whole thing. Okay. Splitted string s. Okay. We need to start with empty here like this. For current c, current s is empty for now. For c in s. Okay. If c in one of these, which is star, sorry, plus, minus, star, or slash. If it is in one of these, then I need to update my splitted what, append my current s into it, and after that I also need to append my c into it. Okay. Else, I'll just tell you what I'm trying to do. Okay. It is going to be empty here again. Else current s dot append c. Okay. So what I'm trying to do is, given this string, I'm trying to build something like this. So I'm trying to build 3 plus 2 star 2. This is what I'm trying to build here. This splitted s is should have this. What else should I do here? I can just do strip so that I remove all the white spaces from it. Let's just check if we got that or not. Okay. Let's print this. So we got that. Okay. So one thing which is remaining is this current s should have updated finally. Whatever is remaining in the current s should get added back into the string. Have this. Second case 3 by 2. Third case you have 3 plus 5 divided by 2. Let's add one more test case here, which is just 3. Okay, and one more test case would be, let's try to run this. What do we get? Is this non-negative numbers are present, so we don't have to worry about that. This is an invalid case. What about now? So you have 3 there. Okay. The answer of this is 3. That's fine. So we got the splitted ones. Okay, so we were able to split it properly now. Now let's go through each and every one and keep track of what was the operator that we have. Okay, so we'll keep a stack, and this stack is basically going to be my numbers present, and then what was the previous operator. Okay, so the previous operator is for now empty. I'll go through my the splitted s here like this. So my whatever that number or operator in splitted s. Okay, if number or operator in this. Okay, if it is an operator, okay, if this is an operator, that means I have to check if this is a star, or a slash. Okay, check if this is a star or a slash. If it's star or a slash, then I need to pop the top element and I do the operation. Okay, that means I need to stack dot pop. What is the stack top? Okay. Whatever is the stack top, I need to get that element and do the operation. Okay, do the operation with uh, next element. Okay, next element, right? So I need to start from here. So I push this into the stack. After that, I see an operator. I store that into the previous one. Okay. After that, I see 2, right? Then I check what was my previous operator. Okay. Previous operator was plus. So add 2 into the stack. After that, I move ahead. Then I check star. Then my previous operator becomes star. Then I went to 2. Then I check 2 and my previous operator is star. If it is star, then I pop the top element and do the operation here. Okay. So this operator is basically, I just need to check, I need to update my previous operator only, and I need to keep track all the numbers. Else stack dot append number here. So I need to just append a number there. So what I have now in the stack is something like this. So my stack is going to have 3. It's going to have 2. After that, it's going to have another 2 there. Okay. Before updating, I just need to check if my previous operator is star or plus. Okay. Is star or slash. If it is, then I need to do a pop first. Okay. Stack dot pop at top. Okay. And then do the operation basically. So previous previous operator is equal to star. Then I need to do dot operator is equal to dot operator into top. Okay. Else I need to do end dot operator is equal to end of slash here. Okay, so this is what I have to do. Let me just think. Do this. So हम लोग क्या कर रहे हैं? What are we trying to do here is basically we are trying to take the stack and then append each and every element in such a way that we have valid numbers in the stack only. And finally, we are going to just put the summation of stack as the answer. This is 2 into 2, right? So this is going to be, before I insert into stack, basically I need to convert it into int. Convert it, then insert it into the stack. No? That this is correct. Convert this also into the int. That's going to the int. This my top is always going to be my. Okay. Let's check the stack here. Let's see if this works. Let's print stack. Stack may we should have 3 and 4. Okay. Hopefully we have 3 and 4 in stack. Why is stack empty? What do we have here? So 3 plus 2 into, okay. So I get my stack, which is basically this operator. And stack here. The stack is empty right now. Okay, yeah. We need to check the empty stack. Stack can be empty. How is the previous operator in this thing? Stack is empty. Stack is empty. And the previous operator in print previous operator and stack. What is wrong? Previous operator is empty. Still went to stack. Previous operator. Star or smash. Try to do this. Okay, something happened here. So we have 3 and 4 here, right? So we have 3 and 4. We just have to do summation of that. We have 0 here. 0 there. Because we have 3 by 2. Integer is 3 by 2. This is it, right? Okay, we'll take care of that in a bit. Let's fix this also. Somehow that thing is getting right answer. You know, right? So if the previous operator is star, then I need to do the multiplication with the top. If the previous operator is a division, if it's not a star, then it's a division, right? So I need to do a division here. My division, convert it to an integer first, then just do a division here. So whatever is the integer, get that out. Okay. Then when you return, you just basically return the sum of stack. Try to see this. This is taking a long time. So this is not working for this. It's not working for division. It is not working somehow. Why wouldn't it work for divisions? So pi by 2. What is wrong with this? Pi by 2. What could be wrong with this? Pi by 2. Let's try to print here. Print or top. Let's get rid of this. Oh crap. So we need to get the top and then this. So we need to get top and then divide it by the this. Okay. So this will have. All right. So just to explain what we did, first we have this particular string, which is s is equal to all of this. We're going to split the string in such a way that we have all the numbers and all the operations separated out. So we have that done in this particular part, which is this part. After that, we have a stack. The stack is going to basically keep track of all the numbers and what should those numbers should be added. And then we also keep track of the previous operator. The previous operator is plus or minus, then it's fine. If it is not, then you need to do the multiplication here like this. One thing which might fail here is when we are minus. Okay, let's try to take a look at when we are minus 3 minus 2. So when you have 3 minus 2, your previous operator is going to be this value. If your previous operator is not one of this, then okay, if your previous operator is minus sign, okay, if it's a minus sign, that means we have to change this idea. Okay. Just do it like this. For the sake of ignore the bad code part here. So just multiply this with a boolean here. Not with the boolean. If it is negative, okay, if my previous operator is negative, then I need to change this here like this. So I need to do this equal to minus plus. I need to add minus sign there. Okay, so let's add one more test case here. 3 minus 2. Minus 2. Let's try to run this. So 3 minus 2 also works. All right, so just to revise everything that we did just now, okay, this might feel a little bit simpler, but it is more complex than what I thought when we started out. So first thing that we did was splitting. For splitting, we used this for loop. After that, we kept track of what was the previous operator, and then we used the stack to make sure that we're doing the previous operator multiplications correctly. Okay. Correct now. Time complexity and space complexity of this. The time complexity of this, because we are going through all the numbers, because we are going through the whole string, the time complexity is O of n. Space complexity of this is again O of n, because we are storing the whole string. Okay. We have space complexity and time complexity both. Okay. We can also avoid doing this for loop here. This is just for the sake of simplicity. We don't really need to do this for loop. If you can intelligently keep track of what was the previous number and what is the next number that you're seeing, you can also solve it without using this for loop. But this for loop makes it more cleaner and simpler to explain and talk. Go to the next question quickly. Valid palindrome. This is an easy one. You're given a string. Sorry, I need to say this right. Let's do this last quickly. So what is given to us? We are given a string, and we want to send if this is a valid palindrome or not after deleting one character. So for example, this is ABA. We don't need to delete anything, and it's going to be a valid palindrome. You have ABCA. You have to delete this C so that you can get a valid palindrome. Else you won't get a valid palindrome here, because this is not. If you remove C, then you're not going to get a valid palindrome. If you don't remove C, it's not a valid palindrome. Palindrome number string is basically a string. When you read it from right and read it from left, it is going to give you same word. Okay. Cat. The palindrome. C-O cat. That to cat is a valid palindrome. Okay. If you add any character in here, then you have to remove this to make it valid palindrome. Okay. Question is saying you want to remove at most one character from it, not more than that. Okay, so what we can do here? Length is 10 raised to power 5. We have ABA, so I can start from here. Character C. Whenever we have palindrome, we should start thinking about using uh, 2 pointers. Okay, palindrome questions would usually be solved using 2 pointers. 2 pointers is name of the pattern, or it can also be used by solving it can also be solved by using stack. Sometimes I'm just thinking about it right now. What we need is we need to remove one character. So this is a valid palindrome. So let's say start from here. I start from here. If I see this is not matching with this, then I need to jump and then check if remaining is palindrome or not, assuming that I'm going to remove this. Okay, so the idea what I'm trying to say is, uh, first of all, let's see how we can check if this is a palindrome or not. So 2 pointer is basically going to have one pointer which is starting from here, another pointer which is starting from here. So there's one pointer which is starting from the start of the string, other is starting from the end of the string. You just keep on checking the start and end. Then you move the left to the right, move the left by one. Then you check A with A. Okay, right one is also moved by one. Then you check C with C. Then you check O with O. You get everything else. It's a valid palindrome. So basically, you want to check if it is a valid palindrome or not. Is palindrome. Okay, let's say we have this function is palindrome, which is going to check for this particular string or uh, custom string. Okay, custom string, if it is a valid palindrome or not. So what we want to do is we want to start from both sides and then merge together. And anytime we don't match it, just return false here. So your left is basically going to be 0, and your right is going to be length of your custom string minus 1. Okay, I'm just taking palindromes right now. Very easy code. While left is less than equal to right. Okay, if custom string left not equal to custom string right, then I have to return false. It is not a palindrome. Else, I want to return true. Okay. I also want to update my left and right here. So my left is going to get updated with +1, and my right is going to get updated -1. Okay. So that is how I check palindrome or not. All right. So if that is how I check palindrome or not. So if I given a string s, I can just simply call return is palindrome. We will check if it is a palindrome or not. Okay. If I run this, then maybe this ABA will pass, but this second one is going to fail because I know I need to remove this C. Okay, how do I remove that C? Is let's try to take a case here. So what I can do is I can run one more 2 pointer here. I can start 1 pointer here. I can start 1 pointer here. Then I can check if these two are equal. If these two are equal, then I'm fine. If they are not equal, then I need to ignore that and check if rest of the string is palindrome or not. Okay. Else, I need to ignore the right side one and check if left side or the whole thing is palindrome or not. Okay. So that will make sure that that is checked by removing both the sides at once, if it is palindrome or not. So what I mean by that is we need one more loop here, which is left, right is equal to 0. length of your s minus 1. Okay, where we want to check while while left is less than or equal to right. Okay, if this path, let's use this one, or if s left is not equal to s right. Okay, then I want to do one thing. I want to remove the left one first and keep only the right part, and then check if remaining is the palindrome or not. So is palindrome. Okay, is palindrome what? My custom string is basically going to be my s left plus 1. Okay, how far? All the way to my right, including the right. Okay, or do one thing, remove the right one. Okay, and keep the left one. Okay, so what I'm trying to say is a b c d. Okay, so if this is the case, then my a is, so let's add d here for now. Let's just take this abc, right? See, this is the case. So my a is equal to a. I'm fine with this. Then I check my b is not equal to c. If my b is not equal to c, what I'm trying to say is I can ignore b and then check only c, if c is a palindrome or not. If it is a palindrome, then it's a palindrome. That means I can remove b and still get a palindrome number, character or string. Else I can remove c and check if it's a palindrome or not. By removing b or c both, I'm going to get a palindrome. I'm going to add b here for now, and I'm going to add let's say b here. Okay, let's say what happens. Let's see what happens here. This a is equal to a, so don't have to worry about that. Okay, this b is equal to d. No, it is not. So I have to do one thing. I have to remove this d and check if this is palindrome. Okay, if this is not a palindrome, then I have to check by removing this and see if this is a palindrome. If both of them are not a palindrome, that means removing one character is not going to solve the problem. You need to remove more than one character to make it a palindrome. Okay, that is what we're trying to achieve here. Left plus 1, right. Works. Time complexity of this is again of n. Space complexity is again of 1, because we're not storing anything here. We're just using left and right pointers whose space complexity is O of 1. We just have the string and we're just passing to the string, no time, no space complexities. All right, so that's, although this seems like a difficult problem, easy problem, it might feel difficult when you start solving it, unless you know the technique, which is what I think I recall from the earlier one. But whenever you see something like this, valid palindrome or valid things, most likely it is going to check whether you can use uh, 2 pointers. Okay, now the follow-up question on this is going to be, what if you can have k number of deletions? Okay, if you can have k number of deletions, then in that case I think what you can do is k number of deletions, it becomes dynamic programming problem if I can do a k number of deletions. Yeah, it becomes dynamic programming. Okay, let's ignore that for now. We're done. So we did 5 questions, which is good. Tomorrow again we'll do 5 questions. I'll try to post a machine learning session somewhere in the middle. I'll share the recording. This is mainly to show how I would approach or maybe talk about some templates if I see. If you feel this is going to be useful, feel free to join. If not, you can also go to the recording that I shared later. Okay. But if you join the live sessions, maybe you can ask questions like you saw today. Uh, and also, I'll be talking about the topics. So, for example, I said whenever you see a tree, think about using DFS, BFS in order, pre-order, or post-order traversals. Okay. If you see uh, traversing or evaluating a expression, think of it from a point of view of maybe a finite state machine where you have some states and then you want to go from one state to other state cleanly. Okay, and all the states are defined. It's not like कि इस state के बाद में आप किसी invalid state में चले जाओगे. Okay, so in that case we use the stack and the other part. Alright, so I think minimum removal की बात जब आएगी तभी stack use करना. Kth largest के लिए आप min और फिर max heap use कर सकते हैं. Things like that can be useful when you are attending the live session. Okay.
Thank you, sir. Actually, thank you. Like you are taking time for this. This will be useful. Like, at least it will get discipline to solve regularly this question.
Yeah, makes sense. Yeah. Try to join this. Just don't get disheartened. Obviously, I have solved these questions earlier too, so I can recall from my things that I've solved earlier. Okay. I don't expect that कि आपको immediately आ जाएगा ये. This is a slow process, but eventually you'll get there. Uh, Once I go through this full uh, burst of questions for the next 14 days, I think I can take a pause and start thinking about merging all of this in such a way that we can learn them in a systematic manner, such as going through the templates, going through the questions. But let's do the way we are doing it right now, and then uske baad mein I'll formally solve them by like एक एक template, एक एक topic लेके हम लोग solve करेंगे. Dynamic programming अभी के लिए skip करने वाले हैं. Dynamic programming is not required for most of the programming rounds. Backtracking useful होता है, so backtracking useful होगा, but dynamic programming आप skip कर सकते हो अभी के लिए. Okay, I'm going to stop the recording now, and then I'll share the recording once. Right? Chalo. Bye everyone. I'll see you all in the next session.
Sir, one out of the box question. Like, can you stop the recording?